Okay, kids, so today in math we're talking about polygons and circles and perimeters. So perimeter is kind of a review. We're just going to use perimeter with some of the polygons that we've been studying. So um, old fact, new way of using it, okay? And we're going to be talking about how circles are shapes, but they're not exactly a polygon. So we need to think about what the definition of a polygon is. So let's take a look. Um, so remember, polygons, this part of the word right here, poly, means many, okay? So a polygon is a closed plane. Remember, that's just a flat figure, okay? It's a closed plane figure with many sides. So here is what a polygon has. Okay, it doesn't have any openings. It's closed. Okay, so think of a triangle, think of a square, think about how all those sides meet, and so there's no openings. It's a closed figure, so no openings. They're flat shapes. Okay, and they have many sides. So that's what the definition of a polygon is. Okay, so I gave you some examples and non-examples. So here, this is a polygon because it's closed. There are no openings. It's a flat shape and it has many sides. Okay, so that would be considered a polygon. Look at this shape right here. Okay, it has an opening right here. Okay, so that doesn't make it a polygon. It is flat, but look at, do we even have any line segments making a side? No, these are all curves. So we don't have any line segments. So this is not a polygon. It's not closed and it doesn't have many sides. So this would not be a polygon and this would be a polygon. So remember, polygons are closed. They don't have any openings. They're flat shapes and they have many sides. Okay, so let's move on. So sometimes with polygons, we can call them, well, let's start this first. Okay, so let's take a look at this polygon. I know it's a polygon because it's a closed figure, right? No openings. It has many sides. I see 3 sides there. It's a flat shape. So this would be considered a polygon. And the specific polygon it is a triangle because of the word the root tri that is giving us the meaning of 3, okay? So remember, a side of a polygon is made out of line segments. So here's a line segment here, that equals 1 side. Here's a line segment here, that's making a side. Here's a line segment here, and that's making a side, okay? When we have 2 sides to come together, we have what's called an angle. So those corners are called angles. There's an angle here, and there's an angle here. Okay, and when 2 line segments come together and share an endpoint, okay, see how this line came together and touched this line segment, and they share this point right here, that's called a vertex. And remember, the plural for vertex is vertices, right? So there's a vertex here, and a vertex here, and a vertex here, so we have 3 vertices. Okay, so let's move on. So there's 2 terms I want you to know. Irregular and regular. Irregular and regular. So when we're talking about polygons, we can call them regular, like a regular triangle or a regular quadrilateral, by if it has the same length of sides. See how all the sides on this triangle are the same length? So we call that a regular triangle. Here's a quadrilateral. It has 4 sides and they're all the same length. So that's called a regular quadrilateral. Now look at this triangle. Still a polygon because it's still a closed figure with many sides, right? So it's still a polygon, but we're calling this an irregular triangle because look at how this line segment is much different than these 2 line segments. So we call that irregular. Okay, here's another quadrilateral. It has 4 sides, still a polygon, but we call it an irregular quadrilateral because the sides are different lengths. Okay, so regular means the sides are all the same length. Irregular means the sides are different lengths. Okay, all right, one last thing to talk about, and that's this circle. Okay, circles are a little tricky because we're so used to identifying it as a shape, but it is not considered a polygon because remember, polygons have many sides. And look at the circle. It doesn't have any line segments in it. It's just a curve that keeps on going. Now it is closed, yes, but it doesn't have any sides, so we can't call it a polygon. We consider it its own special shape. It's called a circle, and it's really a closed curve. It does not have any line segments making a side, okay? So I know that was a lot of information, a lot of it's review, but let's practice with that now. Okay, so I want you to get page 249 in your workbook, and we'll go through some of this together and some on your own. Okay, so it's asking us to identify the number of sides, the number of angles, and the number of vertices, and they also want to know if there are any right angles. Okay, so remember, right angles are those perfect corners that make a square in the square shape, right? The perfect L shape. And we can always put our Post-it note or an index card or a book page right in that corner. And if it lines up perfectly, that's a right angle, okay? Let me show you here. I'm going to try and line up. Ooh, see how that one does not fit, okay? Let's try this one right here. No, not exactly. So we have to look to see if it's a perfect square corner, perfect L shape, to see if they're a right angle. Okay, so let's look here at this triangle. Oh, there's some special instructions here. Color the one that is not a polygon. Okay, so which one of these is not a polygon? Remember, a polygon is a closed plane figure with many sides. Can you guess? That's right. This one has no sides. So this one is not a polygon. So you're going to color the one that is not a polygon red, and you're going to color the one that is a regular polygon blue. So remember, a regular polygon, all the lengths of the polygon, all the sides are the same exact length. Okay? So I can see this length is different than these lengths. So this would be irregular. This one, these two sides are the same, and these two sides are the same, but not all four sides. So this would not be a regular rectangle or a regular quadrilateral. It's irregular because not all the sides are the same length. Now the square right here, this is a quadrilateral. It has four sides, and look at how each of the sides is the same length. So this one is considered a regular polygon. So this one you can color blue. Okay, so let's take a look. How many sides does the triangle have? Easy. 1, 2, 3, right? It has 3 sides. How many angles does it have, or corners? 1, 2, 3. Remember our pattern? However many sides our polygon has, that's how many vertices and angles it has. Okay, so vertices, that's where the two lines come together. There's one there, one there, one there. That's 3 vertices. And this one we found does not have any right angles. We can't make that perfect corner out of it. So 0 right angles for the triangle. Okay? All right, let's look at the rectangle. How many sides does it have? You say it and then I'll say it, okay? Good, 4 sides. How many angles or corners do we have? That's right, 4. You guys know this pattern, right? How many vertices does it have? How many points does it have where the lines come together? There are 4 of those also. And on this one, we did find that there were some right angles. How many? Correct. There are 4 right angles on that one. Okay, then we're going to look at the square. How many sides? Hope you said 4. How many corners or angles? That would also be 4. The place where the lines come together is a vertex, so how many vertices do we have? We have 4. And on this one, do you see those right angles, those perfect L-shaped corners right there, right? Yes, there are 4 of those. Okay, then we come to our circle, not a polygon, because it has how many sides? 0 sides. Okay, how many angles does it have? How many corners? That would be 0 also. How many vertices where the line segments come together? Well, there are no line segments, so we have no vertices. And of course, if we have no angles, we definitely have 0 right angles also. Okay, so I hope that makes sense. Remember, you're going to color one of these red, one of these blue. Okay, so now we're going to use our review of perimeter. Remember, perimeter means distance around, right? That's what we talked about a couple weeks ago about the perimeter. And to find the perimeter, all we have to do is add up all the different sides, okay? So pretty easy. We can do this with a polygon very easily. So here we have 3 inches for this side, 4 inches for this side, 5 inches for this side. All you have to do is add those up to find the perimeter, right? So we have 3 plus 5, I'm going to write inches in there, 3 inches plus 5 inches plus 4 inches. And I'd like you to add those up, okay? So once you find that, then you can write the perimeter answer right there. What is the perimeter of this triangle? You just add up all the different sides. Okay, so here we have a pentagon because we have 5 sides, and we want to find the perimeter of this pentagon. All you have to do is add up each of those little sides, okay? So you're going to add up this side and this side and this side, okay? You're going to add that up. That's going to be your perimeter. Write your answer there. Okay, let's take a look at number 4 together, okay? So Jada wants to put a fence around a section of her yard for her dog, okay? So here's the section that she wants to put a fence around. Okay, do you notice there's no measurements? So we have to read to see what we're going to do there, okay? So it says she will make the 2 long sides. Okay, so let's look here. Do you see the 2 long sides? Yeah, it would be this one and this one, right? 2 long sides will be each 10 feet long. Okay, so we're going to write 10 feet on this long side and 10 feet on this long side. We got it, right? Okay, then we're going to continue reading. And the 2 short sides will each be 5 feet long. Okay, so these would be the short sides, right? So those would be 5 feet long. Okay. All right, so now you want to know how much fence is going to go around this area. So we would add the perimeter. We would add each of the sides to find out the total amount of fence that she'll need. So I want you to go ahead and find the perimeter for number 4, and you can write that down. Okay? All right, so I want you to go on to the back side. Okay, the back side's kind of fun. You've got a color coding to do. All right, so if you've forgotten how many sides a hexagon has, or a pentagon, or an octagon, you can look on Friday's workbook page 247 and 248 will help you to know how many sides if you've forgotten. Okay, so you're going to do the color coding here. All right. Remember, a circle is not a polygon, but it is still a plain closed figure that we can still use. Now, notice that some of these shapes have a shape within a shape, so be careful with that. All right. And then we're going to do some connect the dot. All right. So we are going to form a polygon by changing these dots into line segments. You're going to draw a line to connect each of the dots. Okay, over here, we can see that we are making little tiny line segments. So this is not going to be a circle. It will be a polygon. So make your lines nice and straight between those dots to find out what kind of polygon it'll be. Okay, and then here you're going to figure out the pattern and tell me what would come next. And then lastly, we talked about this a little bit last week, that we're created by God to do work. Remember, we've talked about that in Bible before. We are created to do the works that He's planned in advance for us to do. And sometimes the works that we're going to do will involve math. And so math is a tool that we can use. Okay, so I am going to attach a question to this assignment. So you don't have to send a photo of this workbook page. I want you just to open that question and give me an answer based on what you did on this worksheet. Okay, I think it'll be pretty clear once you open up the question. Okay, so I don't need a photo of your workbook page today. You're going to answer the question, and then I have also assigned an IXL assignment, so I want you to make sure you check the instructions for that. Okay, have a great day.